So on example 1, here it says solve by graphing. Sine of theta is equal to 1/2. Well, we know how to graph sine of theta. We learned that a while back, and we had a table. All right, remember sine starts at 0 and then it goes up. And it comes down and then it goes back up to 0. And so we can graph this. And we can even expand it going back to negative 2 pi by following our pattern.
Look up and see this crap again.
Alright, so, and then we're looking for where y equals 1/2. So we can graph that. It's just a horizontal line halfway between 0 and 1 there.
300 photos.
And then we can find our intersections, and that will tell us what our solutions are. Alright, so
Is that basically x
remember this line is where y is equal to 1/2.
or y equals 1/2?
What I did is we graphed the left side and we graphed the right side here. And we're looking for where they intersect because that's where they're going to be equal. Now on this graph I can't really tell where that's at. Obviously they're both between 0 and pi though, correct? Which, think about what you know. Sine is a positive 1/2. Sine is positive in what quadrants?
It's a y, so
1 and 2, which is between 0 and pi, isn't it? So those are the two angles, one of them in quadrant 1, one of them in quadrant 2, that would give me sine is 1/2. So instead of using the graph there, let's think about that unit circle. Where in quadrant 1 is sine equal to 1/2? Well, sine is what? X or y?
y.
Sine is my y value. So where is y equal to 1/2? In quadrant 1, it would be at, you need your plates,
Wait, what are we looking for?
It is at pi over 6.
at pi over 6. And in quadrant 2, where is it at?
At pi over 6.
Good. So if we were just looking between 0 and 2 pi, those would be my two solutions. But what if I wanted all the solutions? What would I put then? Well, remember that every coterminal angle to those two angles would be a solution, right?
Yes.
And so we would put plus 2 pi n on both of these to represent the coterminal angles.
I have no idea what's going on.